we go, geometry students. This is the January 2018 Regents exam for Geometry Common Core. Here we go. Let's take a look at this exam. These are going to be the solutions to Part 1. These are the multiple choice questions, questions 1 through 12 of this exam. Without further ado, as normal and as usual, over and over again, please do not cheat off of this video. The Geometry Regents is challenging. So I want everyone to do well. So do the right thing. Make sure you try the problems by yourself first, then come back to me if you need help. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. I thank you for your continued support for this channel because I do this for free. And make sure that you visit my website at www.nysmathregentsprep.com. All these links that I just said to you will be found in the description below. And I use the TI Inspire CX calculator to complete all Math Regents exams. It is a powerful tool. The link is on my website. Links you right to Amazon or Texas Instruments. Their website, they have some computer software as well, just in case you can't afford the handheld device. Without further ado, let's begin this exam. How'd you think it was? And I hope that you did it already. Honestly, this was by far the easiest of the Geometry Regents sequence for Common Core. They decided to lighten up a little bit on you students. So here we go. Enough of my talking, chit-chatting. Here we go. Number 1. In the diagram below, a sequence of rigid motions maps ABCD onto JKLM. Okay, not too bad so far. And then they give us all these angle measurements. If the measure of angle A is 82 degrees, so let's go ahead and label this as 82 degrees. The measure of angle B is 104. Okay, 104. The measure of angle L, all right, so we're over here now, is 121. What is the measure of angle M? So we're trying to solve for this, trying to solve for that angle. Well, how do we go about this problem? Because I was only given one angle measurement over here and two angle measurements over here. What does that really mean? Well, if you go back to the instructions, it tells you a sequence of rigid motions. Well, that means that these two figures are congruent to each other. So if they're congruent to each other, that means that each corresponding angle measure are equal to each other. So what you need to realize is this is a simple rotation around whatever point they're going for. So we need to figure out what angles are corresponding to each other. Well, angle A, in this case, corresponds, meaning that it's in the same location to angle J, right? If we just simply rotate this around, angle A is mapping onto angle J. Those are corresponding to each other. Then we have to realize, okay, well, if angle A is corresponding to angle J, then angle B corresponds to angle K, right? So that's the same thing. They are equal to each other. So angle B corresponds to angle K. Okay, cool. So now we also know that angle C corresponds to angle F. No, sorry, not angle F, angle L. I don't know where I'm getting F from. Sorry about that. Angle L, right? So C in this case corresponds to L. Now, when I say corresponding to you, you should be thinking to yourself, I am now going to take these angle measurements and match them in the other quadrilateral. Keep in mind that there are 360 degrees inside of a quadrilateral, and that will help you later down the road. So what we're going to do right now is label appropriately. So if the measure of angle A is 82, angle J is 82. If the measure of angle B is 104, angle K is 104. Now we're trying to find angle M. Perfect. We just got all of our information that we needed. Let's add them all up and subtract it from 360. So if we're trying to find the measure of angle M, set up an equation if you want to. You don't really have to. But what I'm going to do is I'm going to say angle M plus 104 degrees plus 82 degrees plus 121 degrees is equal to 360 degrees. That's how many degrees are in a quadrilateral, right? So we're trying to solve for that guy right there, angle M. So if we add up all of these, we get angle M plus, if we add up all these numbers on the left-hand side of the equal sign, we get 307 degrees. That equals 360 degrees. Okay, not too bad so far. So now from here, all we're going to do is we're just going to subtract the 307 on both sides of the equation, and we get angle M is equal to 53 degrees. And that, ladies and gentlemen, is the answer to this question. Your answer for this is choice 1. That is the measure of angle M. Not too hard of a question, just had to know your basic rigid motion properties. Just understand that if you have a sequence of rigid motions, the figures are congruent to each other. Okay, moving on to number 2. Parallelogram HAND, hand, is drawn below with diagonals HN and AD intersecting at S. Okay, which statement is always true? So I like these questions. It's asking you for always true. Always true. Not sometimes. Always true. So we know that it's a parallelogram. That's important information. So there are a couple things that you need to know about a parallelogram. And now I'm not going to write it out because it takes me a long time. But if you need the properties of the parallelogram, make sure you go on my website and download my Facts You Must Know code for the Regents exam for geometry. It has all those properties listed for you. But basically you need to know that in a parallelogram, opposite sides are parallel, opposite sides are congruent, diagonals bisect each other, diagonals form two pairs of two congruent triangles, and consecutive angles are supplementary, and also opposite angles are congruent. So all those things that I just listed to you, that's quite important stuff to know. So we know that we're dealing with segments and also angles. So let's go ahead and label our diagram appropriately, and let's see which one is true. So HN, the length of HN is equal to 1/2 the length of AD. So they're saying that HN is equal to 1/2 of AD, which is really just like AS when you think about it, because S is a midpoint of both of the diagonals. So is the pink congruent to the green? No, because the diagonals in a parallelogram are not necessarily congruent to each other, so we don't know for sure about that, because we don't know that HN is congruent to AD. If they were, that would be true, absolutely, but it's not true. So that's no good. Number 2, AS. So the length of AS is equal to 1/2 the length of AD. Okay, well, AS right there is equal to 1/2 the length of AD. Is that true? Seems so to me, right? I think it's choice 2. Because S is a midpoint. Again, if S is a midpoint, it divides a segment into two congruent parts. So therefore, AS is 1/2 the length of AD. Yeah, if you take the whole thing and you split it in half, that gives you the length of AS or SD. In this case, they just chose AS. So choice 2 looks good so far. Let's take a look at choices 3 and 4 just to understand why they are not the answers. Choice 3 shows that the measure of angle AHS, okay, is congruent to the measure of angle ANS. No, not necessarily true. First of all, you can even look at the diagram. This angle is clearly smaller than this angle. And also, they are not alternate interior angles. They just aren't, because they're on the same side of the transversal. So that can't be true. And choice 4 is saying to you that the measure of angle HDS, right here, is congruent to NDS. Again, not necessarily true. A diagonal of a parallelogram does not bisect one of its vertex angles. It just doesn't do it. That's a property of a rhombus and a square. So your answer for this one is going to be choice 2. Moving on to number 3. The graph below shows two congruent triangles, ABC and A'B'C'. Which rigid motion would map triangle ABC onto triangle A'B'C'? Now, I want you to think smart. When you're taking a Regents exam, think smart. We could already tell to me personally, it looks like a reflection over the line y equals x. It just does. If you just carefully analyze or just train your eyeballs to look at these two triangles, as you could clearly see, C prime is directly mapping onto C over some sort of a reflection line. Same thing with B and A. So it's not a rotation. It just can't be a rotation. Because if it was a rotation of 180 degrees, then C would be somewhere over in this vicinity. So that can't be true. So if you go through all of the answer choices, think smart. I just said the reflection over the line y equals x. Well, I see it in choice 4, reflection over the line y equals x. Let's go ahead and try that answer. But how do you verify it's a reflection over the line y equals x? Well, you need to know your transformation rules. We are going to just run a basic check to verify that this is absolutely true. Here's a rule that you need to know. If you are given the coordinate xy and you want to reflect it over the line y equals x, well, what's your yielding result? Well, when you reflect over the line y equals x, you just switch the numbers in the ordered pair. It just becomes the coordinate yx. Okay, so if we take all of these points in triangle ABC, so for example, the point A is 1, 2, 3, 4, 5, 1, 2. So this is 5, 2. Point B is 1, 2, 3, 4, 5, 6, 7, down 2. So that's 7, -2. And point C, that's an ugly C. And point C is the coordinate 1, 2, 1, 2, 3, 4. So that's 2, -4. Okay? So now what we're going to do is we're going to reflect it over the line y equals x. We're going to perform this operation up here. So when we do that, we're just switching the ordered pair. Okay, so let's go ahead and try that now. We are yielding the results of A prime, B prime, and C prime. When we switch the coordinates, that just becomes 2, 5. When we switch these coordinates, we get -2, 7. And when we switch these coordinates, we get -4, 2. Well, does that match what's on here? Well, let's see. A prime is 2, 5. 1, 2, 1, 2, 3, 4, 5. Okay, that's good so far. B prime, -2, 1, 2. Up 7. 1, 2, 3, 4, 5, 6, 7. So far, so good. Now let's try C prime. -4, 1, 2, 3, 4, up 2. Perfect. We just verified by using our transformation rule that this is indeed a reflection over the line y equals x. Your answer for this one is choice 4. And if you go through any of these other answer choices, even if you want to verify using your reflection rules, none of these work. But it's just best to analyze the graph first and then apply your knowledge. So none of these answers work. Your answer is choice 4. Moving on to number 4. A man was parasailing above a lake at an angle of elevation of 32 degrees from a boat as modeled in the diagram below. If 129.5 meters of cable connected the boat to the parasail, approximately how many meters above the lake was the man? Honestly, I don't like that English. I just don't understand why they would phrase it like that. They should really just ask you, how many meters was the man above the lake? I don't know. I mean, maybe that's how I would say it, but they say it like this. So basically, you're looking for the height or the distance from the surface of the lake to where the man is in the sky. So you're looking for this. This is a classic question of SOHCAHTOA, okay? So we're looking for sine, cosine, or tangent. So what you need to do is find your reference angle, and your reference angle is clearly 32 degrees because that's the only angle you have. You can't use it on a right angle. And I'm going to draw my little stick figure here. And what are we given here? Well, we're given x, which is an opposite side, and we're given 129.5, which is the hypotenuse. And remember, in a right triangle, your hypotenuse is always across from your right angle. So we're just using trigonometry. We're finding the function that has an O and an H. Well, if we go up to SOHCAHTOA, O and an H, we are using sine. So since we are using sine, you need to use your handy dandy calculator, right? So what I'm going to do is I'm going to set up my trig proportion first. So you take the sine of an angle is equal to the opposite side over the hypotenuse. So the sine of, in this case, 32 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 129.5. I'm going to make a little bit of room here for myself because I want everyone to see this on your screens. Now, when we're given one of these types of equations, what we need to do is cross multiply. I put that sine of 32 over 1, and we just simply cross multiply these two numbers. So the sine of 32 times 129.5, and then x times the 1. Okay, so we're looking for the answer of x is equal to 129.5, the sine of 32 degrees. We need to type this into our calculator right now. Let's go ahead and do that. Again, I use the TI Inspire. Make sure that your calculator is in degree mode. If you have the TI Inspire, you can look at the right-hand corner. Uh-oh, mine's in radian mode. So I just need to quickly change the settings, document settings. I need to change it to degree mode. Make that default. Okay, so now we have our calculator page. So what I'm doing is I'm typing in 129.5, the sine of 32 degrees, and your answer is 68.6. 68.6. So x is approximately equal to 68.6. We've rounded to the nearest tenth, I guess, because all of the answers are to the nearest tenth. So your answer for this question is going to be choice 1 for number 4. Number 5, a right hexagonal prism is shown below. A two-dimensional cross-section that is perpendicular to the base is taken from the prism. Which figure describes a two-dimensional cross-section? So we are looking for a cross-section that is perpendicular to the base of a hexagon. Well, technically speaking, the top and the bottom are both bases, but since the base is on the bottom, let's go ahead and use the bottom if you want to. So we're trying to find the cross-section that is perpendicular to its base. Well, you should know by now that if you're given a prism and you are given a straight line and a base, that these two lines are perpendicular to each other. So this line right here and this line over here in a 3D space forms right angles. So this is a right angle right here. Now, I'm not going to draw all the right angles because all of these are right angles, but that's just important to know. So which figure describes the cross-section? Well, you're trying to find the shape of what this is. Well, what is this shape? Well, it's a rectangle. And if you chose hexagon, you were thinking of the base, but you're not taking a hexagon and cross-cutting it on a perpendicular. It's just not possible. So your answer is actually going to be choice 2, a rectangle. That's your cross section that you're looking for. You're not looking for the hexagon or the top on the top and the bottom. And triangle and pentagon, honestly, I don't know where they got those answers from, because none of these, to my knowledge, actually a triangle could be a cross section if you cut it on a diagonal, but I'm not sure if you could cross this and get a pentagon. You might be able to, but I don't think so, just by looking at it. But your answer is choice 2, a rectangle. Number 6, in the diagram below, AC has endpoints with coordinates A, -5, 2, and C, 4, -10. If B is a point on line AC and the ratio of AB to BC is 1 to 2, what are the coordinates of B? So what you're looking for is a point given on line AC to split this into a 1 to 2 ratio. In other words, you're trying to find what coordinate would make BC, the length of BC, double the length of AB. Okay, so there are two ways that you could do this, obviously. You could either use the graph, or you could use my formulas that I make really everyone memorize. So there are many ways to do these types of questions. You could use my way, which is the formulas. You could do it graphically, or there's also another formula that you could use, but I'm not using that other formula if you do use it. But really, honestly, anything you do is fine by me. So here we go. The formulas that I usually use is x minus x1 over x2 minus x is equal to the given ratio. And your y value is y minus y1 over y2 minus y is equal to the given ratio. I'll explain what this means in a moment. We're trying to find point B somewhere on this line. So you're given the coordinates -5, 2, and 4, -10. Well, in order to use these formulas properly, you have to make the first coordinate, the very, very first coordinate that's given to you. In this case, it's A. The first coordinate has to be x1, y1. There are no exceptions. And your point C, your other coordinate, has to be x2, y2. Your x's and your y's, just like the standalone x and y's in your two formulas, those remain there. Don't touch those. Now, the given ratio we're trying to find is 1 to 2. Well, how do you write this little guy as a fraction? It's just 1/2. So that's fine. So let's go ahead and just put these numbers in the equation and solve for it. So we get x minus. Now, x1 is -5. So watch your signs here. We have two negatives that will eventually give you a positive. Divided by, now x2. x2 is 4. So we have 4 minus x is equal to the given ratio of 1/2. Now we're going to go ahead and cross multiply this. So this is really x plus 5. So it's x plus 5 times the value of 2, which is what we're doing, cross multiplication, and then the 1 times the 4 minus x. So when we continue to solve this, right, when we continue to solve this, we get 2 times x plus 5 is equal to 1 times 4 minus x, or just 4 minus x. 1 times anything is itself. So now we just distribute that 2. We get 2x plus 10 is equal to 4 minus x. Now we just need to solve for x. Add the x on both sides. Then we get 3x plus 10 equals 4. Subtract that 10 on both sides. We get 3x is equal to negative 6. And when we divide by that 3, we just get x equals negative 2. Okay, so far so good. So honestly, if you know for sure you did it right, your answer is choice 1, because that's the only x value that has a negative 2. But let's just make sure that our y value is correct, right? It's good to be accurate. So let's go ahead and do the same thing that we just did for the x's, but now just for the y. So we get y minus 2 over negative 10 minus y is equal to the given ratio of a half. Cross multiply and solve. So we get 2 times y minus 2 is equal to 1 times negative 10 minus y. Okay. So now I'm going to move this down here real quick because I'm running out of room. So we distribute that 2. We get 2y minus 4 is equal to negative 10 minus y. Add that y on both sides. We get 3y minus 4 equals negative 10. Add that 4 on both sides. We get 3y is equal to, let's see here, negative 6. And we divide by that 3. And once again, we get y is equal to negative 2. So we know for sure that we got this question right. Your answer is choice 1. Now, let's just say that you did not like the way that I just did it. Some of you may, some of you may not. No problem. Calculate the slope of this line. You could do it graphically. Calculate the slope. I'm looking at the slope here. Let's see, starting at point A, and we need to look for a definite point. I'm going to zoom in here. We need to look for a definite point on the coordinate axes. So I see point A. Let's see where this line intersects that we know a point definitely. Okay, so this point, you see this point right there? We know for sure that that is the point negative 2, negative 2, right? That's good. So let's go ahead and calculate the slope, which is the rise over the run. So the rise is actually negative. It's down 1, 2, 3, 4 to the right 1, 2, 3. So your slope is negative 4/3. Okay. So what I'm going to do is I am going to simply plot every negative 4/3 slope on my line. So again, go down 1, 2, 3, 4, 1, 2, 3. That's the point that we just had. Do it again. Down 1, 2, 3, 4 to the right 1, 2, 3. Down 1, 2, 3, 4 to the right 1, 2, 3. So as you could see here, people, there are 3 line segments within this whole line segment. Well, here's the nice part. You're trying to split the length of AC into a 1 to 2 ratio. A 1 to 2 ratio. There are 3 line segments here. Okay, so pick one of them to be one line segment and the other one to be the addition of 2 line segments. So this is a length of whatever it is, and clearly this is double this, because all of these line segments that I just drew are actually congruent to each other. Let's just make up a number. I don't care what the number is. You can make this number 5. I know it's not mathematically correct. I could use a distance formula, but just for the heck of it, call this like the number 5. Then all of these are 5s. Well, 5 plus 5 in this case is 10, so 10 is double 5. So we know for sure that we just found this coordinate right here to be B. And what is that coordinate? Negative 2, negative 2. So we know for sure that we got it right. Your answer is choice 1. Honestly, I do not like the graphing way. I just don't like it. Number 7. An ice cream waffle cone can be modeled by a right circular cone with a base diameter of 6.6 centimeters and a volume of 54.45 pi cubic centimeters. What is the number of centimeters in the height of the waffle cone? So first things first, I honestly like to draw some pictures. Okay, I like to draw pictures. So I'm going to draw myself a cone. Now, unfortunately, it does look 2-dimensional here, so I need to do my very best to make it somewhat of a 3-dimensional figure. So here's my waffle cone, okay? Bear with me there. So, okay, so I guess this, you would call this a cross-section, right? So we're trying to find the height of the waffle cone. So this is the height right here, the vertical height from the vertex to its base. It tells us that the diameter, the whole thing, is 6.6. And the volume, they tell us the volume is 54.45 pi. Okay, so far so good. We need to find the height. Well, they don't just give you the volume formula for no good reason. They want you to use the volume formula to solve for the height. But what is the volume formula of a cone? The volume formula of a cone is 1/3 pi r squared times the height. So we know a couple of things. We know the volume. So we could plug this into the V. We know that the diameter is 6.6. So if the diameter is 6.6, your radius is actually half of that, which is the number 3.3. So we're not actually using 6.6 in this equation. We're using 3.3. So I'm going to take 3.3, plug it into R. What do you know? We just have one unknown. It's the height. We're trying to find the height. So what we got to do, drop these numbers in, solve for the height. So the volume is 54.45 pi is equal to 1/3 pi times the radius, which is 3.3, square it times the height. Let's go and solve for h. So what I'm going to do first is I'm going to honestly multiply everything on the right-hand side by the reciprocal. So the reciprocal of 1/3 pi times 3.3 squared, you just move everything to its opposite locations. If it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. So 1/3. Well, 1/3, the 3 is in the denominator, so we're going to move it up to the numerator. Now for the division. The pi, the 3.3 squared, are all in the numerator multiplied to the number 1. So all of this stuff goes in the denominator. So this is pi times 3.3 squared. Okay? We leave h by itself. Now, once we have this, what we do to one side of the equation, we must do to the other side of the equation. So I'm going to do the same thing to the left-hand side of the equal sign. So we have 3 divided by pi times 3.3 squared. This cancels out with all of this information over here. So now we're just left with the letter h. Well, h is equal to what? Plug all of this stuff into your calculator and you will get your answer. What's nice about the TI Inspire? It's a nice template that you could use. So I'm going to use controlled division. I'm going to type in the number 3 divided by pi times 3.3 quantity squared. Close that off in one whole parentheses, and we're going to multiply this by 54.45 pi. And press enter when you're ready. The answer is 15. So that's a nice clean answer. Your height is 15. We're done with that question. Your answer for this one is going to be choice 3 for that question. Not too bad of a question. You just really have to know your fraction techniques. How to solve for h, or just any variable for that matter, using fractions. Moving on to number 8. The vertices of triangle PQR have coordinates 2, 3, 3, 8, and 7, 3. Under which transformation of triangle PQR are distance and angle measure preserved? So in previous exams, they asked you which of the following does not preserve those two things. They decided to change the wording a little bit. So in this case, they're saying under which transformation are distance and angle measure preserved, meaning it's kept the same. Well, that's the definition of a rigid motion. And remember what a rigid motion is. It's a type of motion that preserves distance and congruency and angle measure. So here's the deal with this. A dilation could be a rigid motion. It's only sometimes. And the only way that that's true is if the dilation is with a scale factor of 1. Other than that, if you're multiplying by fractions of any numbers that are less than the value of 1 or anything greater than the value of 1, that doesn't preserve distance anymore. But it does preserve angle measure, but we're looking for it to preserve distance. So when you hear the word rigid motion, generally speaking, I want you to think of the following terms: a reflection, a rotation, or a translation. Any of these three, always, translation, always, these always preserve distance and angle measure. They never change the size of the shape. So if we look at choice 1, we're given the coordinate xy, and all of a sudden they're multiplying the x value by 2 and the y value by 3. Again, these two numbers are not the value of 1. So this is actually a dilation with a scale factor greater than 1. So these points are not the same as the original. So distance and congruency is not preserved under that one. So choice 1's out. Take a look at choice 2. We're adding on 2 to the x value. So that's not changing anything. We're just adding on a value to increase the value of x. So that's a basic translation. We're moving it along the coordinate axes. And choice, no, I'm sorry, not choice, 3y, that's being multiplied by 3. Again, that's a scale factor greater than 1. So that can't be it, because all of a sudden the y values are being scaled or dilated by a scale factor, in this case of 3. Choice 3 is showing, x is being multiplied by a scale factor 2. Again, that's a scale factor greater than 1. So that's a dilation changing the distance. So that can't be true. And it doesn't matter what the y value is because the x value already changed. Take a look at choice 4. X plus 2 and y plus 3. That's your answer. This shows a translation. And a translation preserves distance and angle measure in this case. This is just showing a translation of an x value to the right by 2 units and then up by 3. That doesn't change anything. So your answer for this one is choice 4. Number 9. In triangle ABC shown below, side AC is extended to point D with the measure of angle DAB is equal to 180 minus 3x. The measure of angle B is 6x minus 40, and C is x plus 20. What is the measure of angle BAC? So we're looking for the measure of angle BAC. We're looking for this angle right over here. Well, we're given all these angle measurements. We're not given this one. So unfortunately, you can't use the theorem where you add up all of these and then you just set it equal to 180 degrees. I wouldn't recommend that because we don't know for sure if that's the value of x because we don't know what all of these angle measures are being based off of. So honestly, I would not do that if I were you. What I would do is this theorem. This is a nice theorem. I like this theorem. It's also fun to say. I don't know why. I'm just nerdy that way. So the theorem is an exterior angle is equal to the sum of the two non-adjacent interior angles. So you're probably saying to yourself, Trevor, what the hell did you just say to me? Well, I'm going to show you right now. What does all this mean? So the exterior angle, the angle outside of the triangle, in this case, it is 180 minus 3x. That's your exterior angle. It is equal to the sum, meaning the addition of the two non-adjacent interior angles. Non-adjacent means not next to the angle. You see how the blue angle is right next to the purple angle or the pink angle? Well, the yellow ones are the non-adjacent, meaning they're not next to that angle. So basically what you're doing is you're taking this 180 minus 3x and setting it equal to the sum of these two angles. 6x minus 40 plus x plus 20. Solve for x and you got your answer so far. Thus far, we need to solve for x. So we're going to solve for x on the right-hand side, combine like terms and solve. So we get 180 minus 3x is equal to 6x plus x, which is 7x. Negative 40 and 20, that gives you minus 20. So now we're going to add the 20 on both sides, right? We're going to add that 20. And we get 200 minus 3x is equal to 7x. So far, so good. Let me rewrite that a little bit bigger because that is getting very, very small. So we need to solve for x. Add that 3x on both sides. Add it on both sides. So we get 200 is equal to 10x. Divide by the 10 on both sides. And we get x is equal to the number 20. So now we know that x is 20. So far, so good. We're almost there. So if we take the number 20 and plug it back into the 180 minus 3x, let's do that right now, and I'll show you what it does in a moment here. 180 minus 3 times 20. That gives you 180 minus 60, which is 120 degrees. That's not your answer. It's not your answer. This angle right here is 120 degrees right there. What's the angle next to it? It's 60 degrees. The reason why is that this is a supplementary angle. It's a straight line, and all straight lines equal 180 degrees. So how did I solve that? I just took 180 minus the 120, you get 60 degrees. And that, ladies and gentlemen, is your answer. Your answer is choice 3 for that question. Again, those are one of those questions that you just have to know how to do. Not too bad of a question. Number 10. Circle O is centered at the origin. In the diagram below, a quarter of a circle O is graphed. Okay, so far so good. Which three-dimensional figure is generated when the quarter circle is continuously rotated around the y-axis? So we're talking about this quarter circle, and we're trying to solve or find which three-dimensional object. So far we're given a two-dimensional object. We have to basically put this in a three-dimensional space. So when we continuously spin it around this axis, the y-axis, what shape is it forming? Well, it's spinning. Oops, I should really use a different color. We're spinning around this axis. Well, what happens when you spin it around like this? It's going to create a hemisphere. if you have a quarter of a circle and you spin it around one of its vertical axes, or even if you spin it around the x-axis, regardless of what you do, it's still going to create a hemisphere as long as you spin it around, in this diagram, either the x or the y-axis. In this case, he asks you for the y-axis. It's still a hemisphere. Your answer for this question is going to be choice 4. Number 11, rectangle A prime, B prime, C prime, D prime is the image of rectangle ABCD after a dilation centered at point A by a scale factor of 2/3. Which statement is correct? So we know that the distance is being changed in rectangle A prime, B prime, C prime, D prime because it's telling us that it is the image of a dilation with a scale factor of 2/3. So since rectangle ABCD is the pre-image and we're dilating by a scale factor of 2/3 in this case, rectangle A prime, B prime, C prime, D prime is actually smaller than the original rectangle because this fraction is less than the number 1. So it's asking you for perimeter and area. Okay, fine. So again, I just said that rectangle A prime, B prime, C prime, D prime is the smaller of the two. So this is the smaller rectangle compared to the image. The pre-image. So it's asking you for perimeter and area. So the perimeter. Well, let's take a look at choice 1. Rectangle A prime, B prime, C prime, D prime has a perimeter of 2/3 the perimeter of rectangle A prime of ABCD. Yeah, absolutely. This rectangle has a perimeter 2/3 of the original perimeter, and I'll show that to you in just a moment. For choice 2, it's saying that rectangle A prime, B prime, C prime, D prime has a perimeter of 3/2 the perimeter of rectangle ABCD. No, by this number, that means that that it's getting bigger. That's not true. I just said that it's smaller, right? So your answer cannot be choice 2. That means it's getting bigger. That makes absolutely no sense. Choice 3, rectangle A prime, B prime, C prime, D prime has an area of 2/3 the area. No. An area of 3/2 the area. No. So let's talk about what area is asking about. Here's a general relationship that you need to know. In area, the ratio in this case is 2/3. We know that. They tell us that information. Well, the area has to be the scale factor squared. So, but that's not the case. The scale factor squared, well, that's just 2/3 squared, which is just the number 4/9. Well, I don't see 4/9 anywhere on this page. So your answer in this case is going to be choice 1 for that question. Moving on to number 12. The last question of the video. The equation of a circle. X squared plus y squared minus 6x plus 2y equals 6. What are the coordinates of the center and the length of the radius of the circle? So, let's take a look. So the center and the radius. We need to complete the square. Essentially what we need to do. So what I tell everyone to do. Keep your letters on one side, numbers on the other side. They already did that for us. So I see an x, y, and numbers are on the other side of the equal sign. So what we need to do is take x squared, and we need to rearrange these terms. The x's should be with the x's, group them together, and the y's should be with the y's, group them together. So we have 6x, not 6x, x squared minus 6x plus y squared plus 2y equals 6. So now that we just did that, let's go ahead and insert blank spaces or boxes if you want to, and let's go ahead and complete the square. So we get x squared minus 6x plus something plus y squared plus 2y plus something is equal to 6 plus something plus something. And again, what you do to one side, you must do to the other. And the reason why I'm inserting those boxes is you're trying to acquire a perfect square trinomial. In that case, you need to complete the square to do it. So all we need to do in this case is take half of the middle terms, I should say, and just square them. So half of negative 6 is negative 3. Negative 3 squared is 9. Half of 2 is 1. 1 squared is 1. And then just put them over here. Again, that is found by using the formula b divided by 2 squared. Half the middle term, and then you square it. So now once we have this, we now need to factor them. So we factor this, we factor this. So by factoring, I mean to you, from Algebra 1, you should remember, what adds to negative 6 and multiplies to give you 9? What adds to give you 2 and multiplies to give you 1? So that's just going to be x minus 3 plus y plus 1 is equal to 16. Well, let's just verify that. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. Good. 1 times 1 is 1. 1 plus 1 is 2. Perfect. We just added those numbers up on the right-hand side. We get 16. So now let's go ahead and simplify this a little bit further. You should know by now, once you have two binomials that are the same, you could actually combine it and put a squared on top of it. So we get x minus 3 squared plus y plus 1 squared is equal to 16. So now, since this is now in center radius form, the center is positive 3 comma negative 1, and the radius is the square root of 16, which is the number 4. So the center is 3, negative 1, the radius is 4. That answer is going to be choice 2 for that question. And that, ladies and gentlemen, is the end of this video. I hope that it helped you. Make sure that you hit that subscribe button down below and consider becoming a patron on my Patreon page. I would greatly appreciate it. Make sure that you visit my website at www.nysmathregentsprep.com for more math content in geometry and your future mathematical subjects, and I hope to see you soon.